get started and introduce myself. Hi, everyone. My name is Alejandra Guez. My pronouns are she, her, hers. Welcome to today's WISE session. We do have our guest, which is the Associated Computer Machinery at UCSD. They will be presenting on Python. So if you all had a chance to attend our fall workshop, ACM did present kind of the basics on Python, and today's a continuation of the different topics they covered last quarter. So I'll go ahead and pass that on over to Kyle and Jaden.
Sure. Okay. I guess I'll start. So, hello, I'm Kyle. If you went to the last Wise Python workshop, you might remember me. He, him, his also. Yeah, I'll be one of the presenters for today's workshop. So.
Cool. Hey guys, my name is Jaden. I'm filling in for the other workshop, he, him, his, and today we're going to be we'll hand it off to Kyle for kind of the introduction and what we're going to be doing today.
Yeah, so today's going to be more of a hands-on sort of thing where instead of us kind of throwing concepts at you, we'll have you try to follow along to code something along with us. So today, if you haven't figured it out already, we're going to be coding Minesweeper. So we have the code for you to look at the URL we have posted here. So if you would like to look at that and follow along with us, or if you want to just follow along with us and code on your own, that's also fine. But yeah, don't worry if we go, there's a lot to cover, so we might go a little bit fast. So yeah, if the code will be there for you after the workshop if you are confused about anything, or yeah. So basic concepts we'll be covering today are an extension of what we covered already. So like variables, arrays, functions, and whatnot. But we'll also be covering some concepts that are more kind of applicable to writing programs in Python. So we'll be talking about like how to run a Python program, how to read user input, using external libraries, extra functionality with lists that we have that are called list comprehensions, and we'll talk more about later. And we'll also be doing a little bit of recursion today. So that'll be fun. All right. Well, okay. Well, now that I've gone over that, let's just quickly, I'm now going to switch over to the, oh, can you please copy paste that link? Sure, I can post it in chat. Absolutely. Hold on, let me actually just post that to everyone. There we go. All right, hopefully you can click on that. Now, without further ado, I'm going to move over to the my window here. So I've got Visual Studio Code open, and I'm going to we're basically going to get started with coding this entire thing from scratch. So actually, before I do that, I want to actually show you what the end product is going to look like. So let me just copy our solution code over so I can actually run it for you. So just give me a second.
Yeah, it's a good point. Yeah. So, and then while Kyle's doing that, if any of y'all aren't familiar with like Minesweeper, basically it's a game where it's kind of a logic game where Kyle will explain it here, but you kind of have to flag these bombs. So there's these hidden bombs that we don't know. And we have these mines, right? Or mines. And we basically, when we type in you'll see, when we type in a coordinate, we can either hit a mine or not. So this will be, Kyle, you can take it from here.
Yeah, it's not exactly very okay. The window isn't exactly in the best spot, but hopefully you can kind of get the gist of what's happening here. So in Minesweeper you have a board. Oh, thank you. That's very helpful. But in Minesweeper you have a board, right? And if you haven't played it before, your goal is to essentially find out where all the mines are. So there are mines scattered randomly around the board, and you'll also get numbers that tell you like how many mines are nearby each square. So let me clear out a square to show you what I mean. So let's do like 5, 5. That's always a safe bet, right? So as you can see, when I typed in 5, 5, that cleared out this entire area right here. And the ones, if you haven't played Minesweeper before, essentially indicate that there is one mine next to the square. So, and the same for the twos. There are 2 mines next to the square, and we have to find out where the mines are. So let me just illustrate another feature that we have. So to mark a mine, we can flag it. So we just type in the row, column, and an F to indicate that we want to flag it. Done. Okay. Now, yeah, that's essentially how flagging works. And now if I enter a location where a mine is located, so I know that there's a mine at 6-1, for instance. So if I type in 6-1, the mine has exploded and we've lost the game, as you can see, because all the mines are now revealed to us and it says game over. So yeah, this is essentially what we're going to be coding today. So yeah, let's get started.
Cool.
So let me just get rid of all this.
And also, like, if you one thing is like, I know there's gonna be a lot of concepts in code today. One thing, like, advice would be like, if you just want to just listen along and really just retain these concepts, we're just doing the live code to break things down piece by piece. But if you feel like it's too fast for you, we have the full solution code we'll send after, so you can still run it on your own.
Can I type something here, or wait, what the hell? There we go. Okay, cool. Now, okay, so let's get started. First off, let's talk about running a Python program, because if you're unfamiliar with coding, this is probably, you probably haven't like worked with actually running programs in files before, or maybe you've just used an interactive editor or something. But what we can do is to run a Python program, we need what's called an entry point. So we need to tell the computer, hey, if you want to run this file, start here. So in Python, what this basically amounts to is that you need to, okay, so the way Python programs work is that when you give your computer the file to run, it'll basically scan through the entire thing line by line, and it'll basically just execute every single line. So, but best practice is to indicate that, hey, I only want to run this portion if we actually run it from the command line. So to do that, we can type in if __ name equals to main, I think. Yeah, __ main actually, but yeah. So so __ name is essentially the it's information. It's kind of metadata that's contained inside of the interpreter, and that basically tells you information about who's running this file. So it's basically saying, hey, if we're running this from the command line, do this portion. So yeah, and then we can do like print hello world or something. And if I run this, we print hello world. Awesome. Okay, now let's talk about how we're going to kind of orchestrate the how we're kind of going to kind of orchestrate this program, right? So to run Minesweeper, first we have to do some initialization, right? We have to kind of set the board, draw the board, and then make sure that you make sure we have the loop for the game, right? So we're gonna do the initialization first off, and then we're gonna do the game loop. And yeah, we can start from that. So I'll move it on to Jaden, who will talk about first we have to kind of specify like where the mines are. That's the one of the first things we have to do to initialize the board. So I'll let Jaden talk about this next step on how to do that.
Yeah, for sure. Let me get back to here. Yeah. So we're going to game loop. Can you see my code, by the way? Like just me typing on the thing, Kyle? Oh, you can. Or can you see, like, let me see if this works. Yeah, okay, cool.
You are good, yes.
Yeah, so first off, I'm going to make, so like we said, we have to set the mine. Let's actually establish some variables first when we're doing this, kind of for initialization. So we can first off establish a number that has the size of our grid. So like this is going to be an 8x8 grid. So this n is going to be 8. So we're doing n by n for the grid. Okay, and then next what we're going to do is we're actually going to do some things. Well, first off, let's actually do the mines, call it mines number. And let's say this is however many mines we want, right? So we're just declaring variables at this point in our main program. So we can say 8, we can do 9, whatever we want. We'll just say 8 at the beginning. So we have our number of mines and the size of the grid. So now, do you guys see how we kind of have this, it's kind of, but this like 2D grid here of like all of our things. If you guys can see that. Can you see the terminal moving? Kyle? Is the terminal moving or no?
Which terminal?
Oh, just like the one on the VS Code. Okay, it's fine.
Nothing's happening down there for me.
Okay, that's okay. So basically what we need to do first off is initiate the actual the grid. So we're gonna actually use this thing in Python, and this is gonna be called a list comprehension. And we're gonna have two things. So we need the actual values of the grid, and we need the values that the user sees, right? So there's like a source of, so think of it as like a source of truth, as in there's these actual values that actually have, like it says it has the mines, it has like the number of things around the mine, and then we have the apparent values, or the apparent values of the grid. So the things that we see, right? So at the very end, how do we make so there's a thing called so we were kind of last time going over lists and arrays, right? So there's a thing called 2D lists or 2D arrays. And I can actually print this out for you to just show you how this is. So this is called a list comprehension. And what we're doing is we're actually doing a for loop. We went over for loops last time. This is a little bit hard to understand at the very first time, but we went through for loops in kind of 1D. But this is kind of saying, okay, for every x in our range n, we're going to sort of make this list for y. And if that doesn't make sense, I'm just gonna print numbers here and show you what this actually shows us. So you can see here, if we kind of like, I know this is, you can see the terminal, right, Kyle? Like what I did. Yeah,
you're good.
Okay, so like, yeah, that's great. It can have the 0, 0, 0, and stuff like that. But sort of, if we make this into like a 2D list, like a 2D matrix here, if you kind of put it there, then we're establishing all the values at 0. We're going to do the same exact thing for the mine values, right? So at the very end of the day, we're going to have a numbers, and then we're going to have this is going to be called the mine values. And this is like the apparent values of our thing. And we can just put this as like an empty string. So basically, we're initializing the grid, right? We're actually, because we're going to have to do operations on that grid. So we're basically just making these blank grids, blank slates, stuff like that. Lastly, we're going to have a 1D or a 1D list that is kind of the flag. So this is going to be, I don't know if we went over tuples, but this will be like coordinates, or I think they are lists. So they're like positions. So 1, 2, this is basically something to just store where the flags are. So I want to put like how Kyle put an F at like coordinate 2, 2. Then basically in this flags list, we'll have a 2, 2, and then etc. So we're going to have a flags list. And then lastly, we're going to actually do the function. Okay, so like I said, there's these really cool things to abstract this away from kind of just like, it's kind of cluttered, right? If we put everything in this main method. So we can actually abstract this away, and we can say, okay, I want to declare this function called setMines. And now on top of here, kind of to just see, it's giving us an error, right? Because it's saying like, where is setMines? So yeah. So now at this point in time, right, we're actually going to make the actual value called. So this is going to be a function. We're going to say setMines, right? And this is a function, right? So this is basically a definition, and we're calling this setMines. And when we're invoking the function, it's going back here. So it's a really good way to organize your program and kind of abstract things. So let's actually set the mines, okay? So first off, these variables are lodged within the main program. So a really cool thing in Python is you can make global variables. So you can say global numbers. So what this basically does is it says like, oh, like all of these things in main. You can also, this is just better practice, but you can also take the values established in main. So we're saying this is going to be a global variable. So like this numbers array that we printed of all zeros is going to live in setMines. So we're saying global numbers, global mine values. I think it should be called, yeah, mine values. And we're also going to say, oh, sorry, this wouldn't be the mine values. It would just be the mines numbers. And lastly, we're just saying the dimensions of the board. We can pass those in as parameters, yeah, but Like you can also pass these in as parameters, but we can just make these global variables. Okay, so anyway, let's track the number of mines that we need, right? So let's declare a count variable, and we're gonna do this thing called a while loop. So while the count is less than the number of mines. So what does that mean? So basically, if we have 8 mines and our count is at 0, this while loop is gonna run, right? It's gonna like increment the count, right? So we can just say count equals count plus 1, and it's gonna do some logic where until it gets to this mines number, it should be mines number, we're gonna keep incrementing the count. So anyway, now we need to populate it into a random position. And I think Kyle was mentioning external libraries. For this, we can actually use a thing in Python called random. This is basically a random function for functionality to generate random numbers. And if you're curious on the implementation, I would definitely look it up. It's really cool. Okay, so anyway, we're gonna basically populate random coordinates with these mines, right? Because we don't want, like, it would be so boring if the game had like one mine position. So we're gonna say the value that we want is going to, we're just generating a random integer right now. So we're gonna say random.random integer, and we're gonna say 0 to the range of n times n minus 1. So this actually generates it generates a random integer in the product of our coordinates. So it's 8 by 8, right? So we have 64 possible positions, but since we're doing indices, it'll be 0 to n minus 1. So basically just think of it as it generates a random coordinate in our board. That's great. We have a value, but how do we get the row and the column? So for the actual row, we need to take the value and divide it by 10. So like, let's suppose we're at like, we get 30, right? If you get 30 and then we divide it by the number of 8, we'll get the row number that it's supposed to be on. Basically, if we were to count this as like 1, if you were to count 1, 1 as like 1, 1, 2 as 2, 1, 3 as 3, 1, 4 as 4, we're kind of doing that. And it's basically giving us the coordinate. And the same thing with the column, but for the actual column, you have to do the value, and then you have to modulus it by n. So this is kind of like a trick to get the row and column based off of this, this value that we have. Okay, and then lastly, what we're going to do is we need to check if the mine is in place already. Like when we're setting a mine, and let's say like we set a mine at column 2, 3, we don't want to reset the mine at column 2, 3, right? We need to check if that mine has been set before. So if the numbers at our row and column, right, is not equal to -1, because how we're going to define our mines are -1s. So if it's a -1, we're going to skip it. If it's not equal to -1, well, in this case, we need to update our count, right? And then we're going to say the numbers of our row and column is going to equal to -1. So we're going to set the mine here. And then lastly, we'll do set mines here. And we will print our numbers and show you that the mines will be set. So you can see here that given 8 mines, this is going to be our 2D board. We know that we've generated 8 random nines. So 1, 2, 3, 4, 5, 6, 7, 8. So that's how we generate. And if I do this again, you notice how the mines are constantly going to be in different positions. So we're generating 8 random mines. So anyway, that's how you do set mines. And then I'll pass it off to Kyle to kind of do the set values, stuff like that.
Sure. So like Jaden just said, we not only do we have to set the okay, so what Jaden did is he set the locations for the mines. What we're doing now is we need to set locations for the values of each square. So by values, we mean the neighbor count, essentially. So, well, not really neighbor count. So each square is going to display how many mines are next to it. So yeah, let's get started on that. So we'll call this function set values. Start off with, oh my God, def set values. And oh, I need to avoid following Jaden first of all, because it's gonna mess up everything. Okay, so we're gonna do the same thing as last time, where we basically did global of numbers. Actually, let me check that. Yes, global numbers, and because numbers is the array that we want to update, and then global n is the board dimension, so we'll import that as well. Okay, well, that is not correct. Anyway, now we want to basically loop through every item inside of numbers. So another way to kind of do it, well, Jaden used a while loop. We can also use a for loop. And let me actually show you how that's done. So with a for loop, we basically iterate through the rows and columns of each of the numbers array. Because numbers is in this case, it's an array containing 8 lists or 8 arrays of 8 numbers. So we can do for row in range n and for call in range n, and then we can do and then numbers of row column is going to give us the exact number at that particular row and column. So yeah, now that we have that, so we can start to kind of, now that we have that, we can kind of start to figure out like where the mines are. So for each square, we need to check each of the 8 squares that surround it. So to get that, we need to basically do math on this row and column. We need to subtract 1, add 1, do whatever, right? So first of all, we want to check if the current square is a mine. So let's do that. So if numbers row call equals -1, there is a mine here. And if that's the case, we don't want to do anything, so we continue. And continue, if you don't remember, basically means that you skip over this iteration of the for loop and move on to the next one. So yeah. And then we need to check each individual neighbor. So we can do that by just doing a bunch of if statements. So this is going to be annoying, but we will do it. So check top left. If numbers row -1 call -1 equals -1. Now this will basically say, okay, if I am at this square, I want to check the square that is above and to the left of my current square. One particular issue with this is that what if you're in the top row? If you're in the top row, you can't go up. Or let's say you're like at the very top left corner. Then row -1 and row and call are 0. So row -1 and call -1 is going to be out of index. So I mean out of bounds. So we need to also check if everything's in bounds. So let's try row is greater than and call is greater than 0 and numbers. Yep. And then if this is the case, we can do numbers row call plus equals 1. And it's basically going to be the same thing for a lot of the other cases that we have. So let's do above. Check directly above if. Now we're only subtracting the column this time, so we want to make sure that we're only subtracting the column this time, so we want to make sure that the column is greater than 0. And numbers row call wait, this is directly left. My bad. So this is directly left actually, because column is left to right. So if row call is greater than 0 and numbers row 1, yeah, numbers row call -1 equals -1, then numbers row call plus equals 1. I see chats kind of going off right now, so let's see if we have any question. Oh, nope, it's just is it common to use global? Stone asks. Jaden answered that question already. Okay, cool. Okay, now we've got the column. Now let's get check bottom left. So if now we want to check if so at the bottom left, we want to check if we haven't gone past the bottom yet, right? So row needs to be, if row is less than or equal to, no, if row is less than the number of rows. So row, if n is, okay, so if n is 8, then row, the biggest value row can take will be 7. So if row is less than n, that's correct. So if row is less than n and call is greater than 0, and numbers row plus 1, call minus 1 equals to minus 1, numbers row call plus equals 1. Okay, I'm just going to speed through the rest of these. This is really tedious. So, so we're going to, obviously we have to check directly above, check directly below. That's not how you spell below. Check top right, check directly right, and check bottom right. Now we do if directly above is going to be row is greater than 0 and numbers row minus 1 call equals to minus 1. Then you need to check directly below. Row is less than n and numbers row plus 1. Column equals to minus 1. I'm just going to copy paste this because it's really slow. Then we want to check the top right. So if row is less than n and call is less than 0, greater than 0. No, row is actually greater than 0 and call is less than n. This is going to be row minus 1 and call plus 1. Yep, and then on the right, it's going to be call is less than n and call plus 1. And then at the bottom, it's going to be row is less than n and call is less than n and row plus 1 and call plus 1. So yeah, that's essentially it for set values.
I think one last thing, Kyle. I think that was good. I think it's just n minus 1 instead of n because when row is less than n, that's kind of saying like n is the size of the board. So then that means that if a row is 8, then it would go out of bounds. So it would be n minus 1.
Ah, yeah, that's right. Thank you for catching that.
Yeah.
So let's change all these to minus 1. What I missed. I think that looks okay. Nice. Okay. And then we can just go to the bottom here and then call that function down here, set value. All right. That part is done. Now, on to Jaden again, who will go over. Well, next we're going to put the instructions because we have to tell the player how to play the game. So Jaden will go over that next part.
Of course. And yeah, for like just like clarification for all the stuff we're doing, there's like full compiling code. Like even if we make a mistake or something like that, this is basically just like getting this topics to you, right? And sort of stuff like that. So we don't want to get carried away on like the sort of just like the very like nitty gritty things. We just want to give you the good things. So anyway, for this part though, so basically every game, right? Kind of at the beginning of the game, we had instructions. This is like very straightforward. Of like how we're gonna kind of display all the instructions of the game. So you guys can see my screen. I'm on line 55. Yeah, okay, cool. So yeah, we're gonna do a def instructions. Basically, we're just gonna like prompt the, basically we're setting all these values, right? We're like setting the values, I think it should be called values. And we are saying, okay, so now, basically, what I'm going to do is this is very straightforward. Honestly, we're just calling a function called instructions. And basically, I just copy and pasted it. basically we're printing the instructions, and it says like enter. It's basically prompting the reader. So pretty self-explanatory. At the end of that, we're gonna call set instructions. So let's just get out of this print statement and call instructions. Cool. So now like this method runs and we actually get a prompt, right? Like for the reader. And now I'll discuss like the things about the actual game loop, right? So the thing about the game loop is that for a lot of games, right, we want this game to keep looping and looping and looping, kind of like how we don't have a condition and we want to keep the game looping while the player has still things in it, right? That's called a game loop. And so we can define this variable called over, and we can set it equal to false. So at the beginning of the game, obviously it's not going to be over. And when a condition gets hit, maybe you hit a mine, maybe you win, maybe you exhausted all your possibilities. We're going to set game over to true, and that kind of ends the loop. So we're going to say like while the game is not over. So basically saying like while game over is still equal to false, we're going to call this method every single time. And that's going to be called print mines layout. And what print mines layout is doing is basically every time like probably should have the I'll do it. I'll actually I'll put another solution file here when it's your turn, Kyle, and then I'll just like run it just to show people. But yeah, so we'll have that to you in a bit. But like once the solution code actually runs, we want to print that really like pretty layout that we got before, right? Of the entire grid. So let me actually do this. Let me just say Minesweeper, because I want to show you all about Minesweeper 2.py. So we're actually just going to make a quick new file here. And I just want to show you like how this would work. Just so we're on the same page.
I just realized I forgot to follow Jaden again, so that's totally my bad.
No worries, no worries, no worries. Do you see the terminal? I don't know why it's like messed up. But yeah.
So you should be good now, by the way.
Okay, so let me just double check with the zoom. Okay, so basically like the terminal is looking like that. I'm gonna move. Yeah, so if you kind of look at the terminal, there's that really pretty like nice box layout, right? So we're gonna actually print that layout. So I'm on Minesweeper 1 now, the actual one that we're doing. And yeah, let's go ahead and do this at the very beginning. And we're gonna call it print mine layout. Print mines layout. And what we're gonna say is first off, we're gonna take the variables that were defined in main. So it's going to be the actual mine values array. The mine values is basically what we're like seeing. This is the array that we see, right? This is the actual like really nice, pretty formatted thing that we see. And we're also going to take a global n for the n here. I'm getting an error. That is not as a semicolon. Okay. So anyway, let's just do like print some new lines. I'm just gonna print. So this is called like just like titling it. Basically, the /t/t can actually just do tabs, like it does a tab, and then this new lines. So we're just doing some formatting here. And yeah, let's go ahead and get started with the actual mine layout. So at the very beginning, we're gonna initialize this string as yeah, maybe like a couple empty space, a couple spaces. And what we're gonna do is we're gonna make the first row. So Kyle, if you kind of like go to the if you go to the actual terminal and just kind of like scroll, just like expand it if you can. Or I'll just expand it a bit. Yeah, there you go. So like this will make the top, there's actually top values. I don't know why it's cut off, but there's actually top values in the row, but before any of the lines start. So all we're gonna say is like for I in range n, we're just gonna print those values. So we're just gonna say string is gonna be equal to string plus, we're gonna add some space, right? We need some padding for the values, and then plus we're gonna cast the iteration that we're on to a string. So what that basically is like this is initializing our first row. So it'd be like a 1, right? For I in range n, it'll be like a 1, it'll be a 2. Oh, why did I say I plus I? I plus 1, right? So it'd be like a 1, a 2, a 3, and then it'll like add space or padding. So that's actually the first row that we're doing. Okay, we're gonna print just another string. Okay, so now, okay, we got to the first row, right, of like what we're doing and like how we're spacing things out. So now the next thing we're gonna do is we're actually gonna build the bars. So think of like the actual bars, things like that. So for I in range n, we're actually doing another string 3. We're gonna tab that. And basically what we're doing is we'll do one more. We're saying, okay, so if we're on the first row, so if our row is equal, oh, sorry, I think we need to, sorry, this wouldn't be I. Let's just change this to R, because we're gonna go through every single row in our n. So if row is equal to 0, that means we're on the first row, basically, right, intuitively. So for every column in that row, right, so basically we're saying like if the row is equal to 0 for every column in the row, we need the bar to like the upper bar, the bar that kind of like encloses everything. So for every column, we're just going to say string is going to equal the string plus like this. So basically what this is doing is it's like making that upper boundary, like the upper bar of actually when we're doing that. So this is the very special case for the 0th row. Okay, so now we're done with that. So we'll just do the same string. And now we need to build each row to make the format really nice. So basically what we're going to say is like for column in range n. So it's going to go through each column that we have, right? It's 8 by 8, right? So we know that, for example, there'll be 8 columns and 8 rows. So all we're going to do is we're going to build the sort of the left and right boundaries to the bars. See my like hands, like the left and the right boundaries for that. So how are we going to build sort of the left and right boundaries? We're just going to say the string is going to equal the string plus, we need to add the left boundary, right? Okay. And then after like the left boundary kind of has been added, right? However many left ones, then we're going to need to print the string plus our right boundary. So like this basically adds the bars that are like, it's going through each column, right? It's adding like 1, 1, 1, 1, 1, and then it's adding the right boundary after that. So yeah. So anyway, that's basically how the columns work. And then after we add the boundaries, we need to actually add the numbers in the boundaries, right? We need to actually add what the numbers are. So the string is going to equal, string is going to equal to just that. Oh, I'm sorry. This is actually, this part here is just going to be, so you see how like on our terminal we have the above, like if you go to line 14, we have all the ones above, right? Like on the row, like 1, 2, 3, 4, 5, 6, 7, 8. So we need the ones on the side. You see on the side how we have 1, 2, 3, 4, 5, 6, 7, 8. So we're doing that right now for the side. So like we're initializing things for the side. Oops. Yeah, like we initialize it for above. All right. So anyway, let's do that. So initialize the things for the side. So this is saying like, okay, remember, like this is iterating through each row, right? So like for each row, this is happening. So we're establishing the bar on the side of the row. Next thing we're doing is we're going to actually populate the values in the cells, right? Like think of these as cells, like top left, bottom right. We're actually establishing these things in the cell. So basically for every column in our range of n, we're doing a string plus, right? We're actually, this basically is closing the cell, right? So this is basically closing each and every cell. So like left, right, left, right, left, right for each and every single cell, basically. So obviously we need a opening bracket, and then what we're going to do is we're going to say our mine values, which are just our row and column. So this is basically indexing our 2D array for the actual, remember, like the actual mine values here are like the apparent values that we have. So whatever that value is in our index of R and C, right? Because we're iterating through the row and column, we're just going to say, okay, whatever that value is, we're just going to take that and then we're going to add a space. And then at the very end, right, we still need to we need to close it for the right one. So it's going to be called the string plus just a closing bar. So that's basically populating every single thing, right? Because it's going through each row. And then at the very like last one for like all basically like the rows, we're going to make a empty string. And this is basically closing the row. So it's like finalizing the row and closing it, right? We need the bottom. This is like the bottom part. So for C, for C in range of n, we need the bottom part to the row. So basically we're doing string equals string plus, this is closing it on the bottom. And honestly, if this is like really confusing, it doesn't make that sense, don't worry. This is just like making things pretty and formatting. Just trying to like get things to heart. I think the main essential is like the logic of like how this actually works. But yeah, don't think this is too important. This is kind of just like formatting it how arbitrary way you want it. So if you feel like this is a little bit hard, like how are we gonna like do all this, then don't worry about it. But yeah, so we did this. Okay, so basically print mine layout, right? So we set the values. we have the instructions. While the game's not over, we're going to keep calling this function, right? So it's going to keep generating this new like terminal looking board, right? So yeah, so that's the print mine layout. I'll turn over to Kyle to go over like the valid inputs, sanity checks, and like out of bounds stuff.
Sounds good. Okay. Before I do that, however, I just want to make sure that this program's working actually. So actually, you know what? We'll go over input first, and then we'll test it along with everything else. So now we want to do what we want to do is we basically want to get user input. Luckily, in Python, that's pretty easy. We can just call a function. So let's call this input. And then the way to get user input is we basically call input, function called input, and then it takes an argument that is going to basically display a message, and then afterward it'll let the user do its thing. So here we want to prompt the user to enter whatever how to enter the instructions. So enter row number followed by space and column number. That's not how you spell equals to yes. And then just for now, I'm going to do print input because all right. So just to show you that this works, I'm going to print out whatever the user enters, and then we can try and run it and then see if it works. First off, let's actually check. While we're doing that, we can kind of check if the oh my God, that's not good. Jane, you might have to redo the terminal. But yeah, while Jaden's getting that set up, so basically we can just kind of run the program, what we have so far, see if anything's working, see if everything's working properly, and then we can kind of move on to validating this input. All right, thanks, Jaden. So,
are you still shared on this one?
Am I no.
See if you can share it. Configure terminal settings, like default share. Trying to see, because like last one I was able to, maybe I can create a new, we're on the live share. Let's see. Not sure where the share is. Let's see if we can share it. Create JavaScript. So basically trying to get the terminal to share. Not sure how I did that last time. I mean, if anything, I can just do the terminal, but I don't see. You're still on the live share, right? Yeah.
Yeah.
Oh, there you go. Share terminal. There you go. So let's do
Awesome,
read.
nice. Okay.
All right. So it's initializing right now.
All right.
Oh, there you go. You're good.
I don't see it.
Oh, just do. Yeah, I think that's the one. Or you can request read. Oh, okay.
Oh, I just closed it. Okay. I'm just gonna move on and let Jaden set that up for the sake of time. So we want to basically validate the input, right? We want to check whether the input is correct. So first, what we're gonna do is we're gonna call dot split on this. And what dot split does is that it takes words in a string that are separated by white space, and it separates them into an array. So if you call dot split on like a standard English sentence, let me actually demonstrate this. Oh yeah, cool. This works. So Python 3, and then if I do hi, my name is Kyle, dot split. That gives hi space hi, my name is Kyle, but with all the words in split up, right, in an array. So let's exit this. And then if I run, actually, let me quickly do this. So actually, this should still work, right? If I run, wait, hold on. Let's get rid of this for now. Let's sanity check to see if all of our code works. Otherwise, bugging will be a pain. Oh.
Oh yeah, I think some of the print logic.
Okay, I'll let Jaden fix that in the background.
Yeah,
but I'm gonna continue.
Yeah. Like I said, the like I think it's okay. Like they have the code and stuff here. We'll just try to explain like the high level concepts.
Okay.
Yeah.
But yeah. If I type in anything, say hello, I should have printed hello somewhere. It's probably not going to show up because of the thing, but yeah, the terminals. Yeah, Jaden has to resize the terminal, so
Yeah,
It's fine.
Yeah,
I'm
let
just
me resize
going-
it. Is that better?
Yes, you can actually see my typo here, but the point
Okay.
is we managed to capture user input, right?
You can try running it again too. See
It's
if it works.
okay. I cannot type today, but whatever, it works, right?
There you
So it's detecting user input. Now, what can we do with this user input? Well, I'm going to put the dot split back. And then what we essentially want to check is we want to see if the input is correct. So what we can do is a handy thing you can do with Python is that you can kind of Python has what's called like a try except construct. And what you can do with that is you can basically have a bunch of lines of code in your try section. And if they work, they work. If they don't, then you can do something else. So let's start off by validating the row and column numbers. So if length of input is equal to 2, which means that a user has entered 2 words, then we try to convert these words into arrays. So we can do, okay, so here's what we can do. We can do val equals to list map int imp. That's kind of okay. This is what's in our solution code, but it's kind of advanced, so I'm gonna like rework this into something that's actually understandable. So val is equal to int of I, int of s for s in imp. So what this is gonna do is it's gonna convert each for every string inside of input, it's gonna convert that string to an integer. If it can't do that, we run except value error. So we have to specify the type of error that happens here. So value error would be the error that occurs here. And then if that's the case, we print wrong input. And then we do the thing again. So we want to print the instructions and print the board again. Or, okay. Print instructions continue. Yeah, we want to print the instructions and we want to move on to the next iteration. So yeah, that is good. Why is it screaming at me? What is this? Unindent does not match any outer indentation. Oh, isn't that fun?
Let's see.
Oh, I added spaces there. That's why. Okay.
Yeah, Python's annoying with that.
Yeah. Okay. So
You can try it now. You can try.
Okay. So that should work. Let me just see if it does. Hold on.
Oh, I got it. Yeah. I don't. Oh, you can resize it. Yeah, it's weird, right? It doesn't like cut off.
Okay. Good. Okay. Oh, I expected EOF while parsing. Line 134. Oh dear. 134. Ah. How strange. I haven't mismatched any like curly braces or anything.
Yeah, let's see.
We'll worry about that later. Okay, so we also want to kind of make sure that. Wait, what happened?
I don't know. I just threw something in. Try to. Yeah, you can probably run it again. Should be good.
Let me delete the line I just typed in. God, get me out. Oh my god.
There you go.
Okay, run that. Get me out.
It's weird that you can't like drag it up, right?
Yeah. Anyway, so that works now. And then if I type in like 6, for instance, if I type in like A, B, C, D, E, F, G, then it should print out that, yep, wrong input, instructions, cool.
I'll reprompt you. Yep.
Yeah, it does prompt me if I get it wrong, which is good, which is what we want. So now we also need to worry about flags, right? Because to place a flag, we have to specify the coordinates and then add an F to the end. So what we want to do is we want to check if, so elif is going to be else if, length of input equals 3. So user has entered 3 words.
Mhm.
Then we want to check if input 2 is equal to the character f. So if input 2 equals f, or is not equal to f, or and input 2 is also not equal to lowercase f, then we want to do the whole shebang, right? We want to do print wrong input, instructions, continue. Now, once that's done, we need to validate the 2 numbers again, right? So try val equals to int s for in input. And we only want to do this until the second one, so we don't include the f. And then we basically do the same thing as before. So accept value error, print wrong input, instructions. Okay, now we want to, okay, so now we know that if we manage to get past this point, then what's happened is that we have 2 numbers as inputs, which is good. But what we also want to do is we want to check if the values are within the bounds of the board, right? So what we can do is we can do if val 0 is greater than n, or val 0 is less than 1. So 1. So we want to check if, and remember, these are like the number, the actual like row and column numbers. So it's going to be 1 to 8. So we want to check if it's between 1 and 8. And if it's not, we want to throw an error. Okay, now that's done. So yeah, now I'll move it on to Jaden to validate the rest of the input and basically do all that logic of like running the flags and stuff.
For sure. Yeah. So basically, oh, it's this one. Oh, we don't have. Let me see. Okay. So basically, the last basically we'll just like do a couple more things for validation. We'll wrap it up at the DFS that Kyle will do. But essentially now, since we have all of our sanity checks, right, and everything is kind of good, we know that, or not good, but there's still some more validations. We know it's not out of bounds, like Kyle said, we know it's not the wrong input. We need to do a couple more things, right? So first off, let's get the row and the column number, okay? So how we do that is we can just say like row is equal to the value of 0 minus 1. So basically, this is basically in our values array. Of 1. So remember how we like mapped it. Basically, we're getting the row and the column from these coordinates. So remember that these are 2 indices of like values. They have 2 indices, and we're trying to get we're just getting the coordinates right now. So we need to check if that's in the flagged, right? So we need to check if this list, because a flag is just going to be a list of lists. So if this list exists in the list of lists and flags, we're going to do this thing called we're going to clear the screen, and kind of how to implement that is there's a really cool thing like we can do with Python. And let me just, if you can scroll up, Kyle, I'll just import OS. That
Oh,
you can
I forgot to follow you again, my bad.
Oh yeah, no worries. It's just go right before instructions, the definition instructions, and I'll just say def clear. We're gonna call an OS because we imported OS, right? It's a package. OS.system. All this does is this is really cool because it goes into your operating system and it says, oh, you know how we get into our terminal, how we're doing these things, like if we type in ls, stuff like that. This basically takes the command and says, oh yeah, let's perform a clear on your operating system. And this actually works for any operating system. Doesn't matter what operating system you have, Windows, Mac. anything like that. So anyway, we're gonna check if it's in flags. If it's in the flags, we're gonna clear the board to make a new kind of a new board, and then we're gonna say, oops, sorry about that. We're gonna print. What are we gonna print? We're just gonna print the value already, or sorry, we can just say flag already set, right? So the flag already set, and then we're just gonna continue after that. So once we do that, 1 second. Okay, so once we do if it's in flags, oh my gosh, he's calling, my bad. Basically what we're gonna say after that, right, is we're gonna see if the cell has already been displayed. So if mine values of row and column is not equal to this, we are basically going to say, okay, so this is kind of if the cell has already been displayed or not. We're gonna call it a clear method again. And then lastly, we're just gonna say, okay, well, the value is already known, right? So if there's already a value there, well, like there's no use in like traversing it again because we already know it. And we're gonna continue. Okay. And then we're just gonna check if the number of flags has been reached or not. So this is really easy. So if the length of our flags, remember it's a list of 2D lists. If this is like, if our mines number, right, is greater than our length of flags, or sorry, like if we have, still an amount of flags, then we're going to say, okay, we're gonna clear, we're gonna set the flag. So this is the logic of, I think it's called mines number. This is basically the logic of when we have a valid flag. So if we still have an amount of valid flags, right? So we're gonna print like, okay, the flag's gonna be set. And then we're gonna say, okay, we're gonna append our list, right, of row and column to our flags 2D array. We're gonna set that value in the mines array to F, right, for flag. And then we're good. We set the flag. Okay, else, we already have expended our flags, right? So we can just be like print flags finished. And then we'll just continue like normal. Good to go. So this is just, sanity checking. And then else, like for the input, right? So basically, there's this huge if for the while loop. I think it's here. We already did the wrong input. Yeah, we're good. So lastly, what I think we're coming up a bit on time, but I think we have the information for the sanity checks. And one thing I really want to go over real quick is the neighbors real quick. So what we can do, just like since we're running up on time, is let's just we have the solution code so you can see it, but I'm just going to show you. Let's say that the numbers of our row and column is equal to 0. So how Minesweeper works is if 0 means that there's 0 mines around that, right? So it's going to explore all of its like neighbors, all of its surrounding for all the other zeros, and it's going to kind of clear a path. And then if it's a 1 or a 2, the path just gets killed, right? Think of it as like a wall if there's a non-zero number. So that's how kind of like how Minesweeper works. So if the row and column is equal to 0, we're gonna have this visit array of all the things that we visited before. Obviously we're setting the coordinate, right? Like let's say that we like our numbers of RC is equal to 0. We're gonna set that in our mine values array equal to a 0. And then we're gonna call this function called neighbors of row and column. And that's kind of where we'll finish there. And Kyle, I think as a last kind of note, if you can kind of explain to them like what this neighbors function does and kind of the premise behind it.
Sure. So, okay, let me kind of draw something on here to make, okay, before I start, let's actually draw something I'm actually going to draw a grid in order to make things more clear to people who are watching. So I'm going to draw like a 5x4x4 or something.
Yeah.
Yeah, 1, 2, 3. 1, 2, 3. Okay, and let's say we're starting off at this square right here. So
oh wait, I don't think we can. Oh yeah, we can see it. Sorry, my bad.
Yeah, so we have a bunch of zeros here, and then let's say we have like 1, and then 1, 0, 1, 1, 1, 1, 0, 0. Let's say there's a mine like right here. I don't know. There's a mine line right there, then we'd have to get this would be a 1. So draw, undo. God damn it. Erase this and then draw one back. Oh my god. Here, and then we have, actually let's put another mine here too, why not? So let's say we start from this, let's say we pick this square right here. I'm gonna use a different color. So what we essentially have to do if we're just starting out, this board is gonna be completely blanked out, right? If we click on this square right here, what should happen is that this entire section should reveal itself, because that's kind of how Minesweeper works. If you click on a bare area, it will automatically clear all of these squares that do not have nines near them, and it will clear one square that does have a mine close to it. So you basically get this boundary of squares that have mines. So in chat.
And
okay.
yeah, I think and then yeah, so that's basically the high level of what Kyle said. And I think we're like Alejandro said, we're coming up around time. So we have the solution code and everything for the process of how this works and everything like that. Essentially, it's a concept of depth first search and kind of using recursion. I'm gonna do a lot of links to that since it's pretty lengthy to kind of establish, but we have the whole solution code. Let me link you towards that. And yeah, and while I do that, Alejandro, you can totally unmute and kind of give your wrap up to the remaining students.
Hi, everyone. Thank you again for joining. This presentation was recorded, so it will be put on our YouTube channel, the Idea Center YouTube channel, within the next week. And thank you all for coming. I'll just let Kyle and Jaden wrap up.
Yeah, but anyway, Kyle, you can say your words after, but one thing I would say is, I know it's this is pretty intensive, and it's really good to just get exposed to all of these concepts, even though maybe some things might be a little bit hard. But yeah, I think essentially it's really cool because you go to the solution code, kind of code it up yourself, and you have your very own Minesweeper game that you can actually use, and you can kind of show off, be like, yeah, I made this whole thing in Python. So that's something pretty cool. And Kyle, go ahead, you can if you have anything.
I don't really have much to say, but well, thank you all. Thank you to the people who came out, and like Jaden said, the solution code is up on GitHub if you want to look at it. Yeah, this was a little bit hectic because there was a lot to go over, but
yeah, there's a lot.
I would definitely recommend going over the code in your spare time and just seeing what it does and kind of understanding the logic behind it. But yeah, thank you for coming out.
Yeah, sounds good though. Thanks, guys. Thanks, everybody.
Bye, everyone.
Bye-bye.
Thank you.
See ya.
Bye.